A very good morning to all my dear students. Hope you are writing all the assessments really well. And as you know that tomorrow is our science assessment. So let me just recapitulate all the key concepts that we have learned in our chapter acids and bases. But before I begin, let me tell you one thing. Let me just give you a small advice. Children, please take these assessments seriously. You are in 10th class now and you should be taking every opportunity where you can improve in your subject. Please take these assessments in a very serious manner and prepare well. Okay? So let us begin today's revision class, that is about the chapter acids and bases. It's one of the most interesting chapters that we have in our syllabus, children. So like we have already learnt some basic information, or what you call basic points or concepts about acids and bases in our lower classes. So this is just an extension, or what you call, we are just going deeper into this chapter. We have like what we have in our syllabus is almost some we have already learned and some it is new to us. Okay, so let us concentrate on today's revision class and learn perfectly, and in case you get any doubt, please please feel free to ask me and clarify your doubts. Okay, so let us begin with today's first question, which is nothing but what are acids. So as you know that acids are those substances. Simply, if you wish to define acids, then these are the substances which are sour to taste and which are very corrosive and which change the color of the blue litmus to red. So those substances which tend to change the color of blue litmus to red and which have a corrosive effect, which are very corrosive as well as sour to taste, they are called as acids. Okay. In contrast, bases are those substances which are bitter to taste and which are slippery, as well as they change the color of red litmus to blue. Okay. What are salts now? These are chemically neutral substances which are formed when acids and bases react with each other. So we shall learn in detail about all these three now. First of all, you should have an idea of what are strong acids and what are weak acids. So I'll be telling about the definitions of strong acids and strong bases and weak bases when I will be discussing about what acids have in common. That will be coming up next. So before that, let's just give some examples of strong acids. All the mineral acids, actually we can classify acids into two types, organic and inorganic. Basically they are divided into two categories, organic acids and inorganic acids. Inorganic acids, or we also call that as mineral acids, actually, which are formed from the minerals which exist on the earth, which occur in the earth's crust, actually. So from the minerals we get mineral acids, and from the vegetables and fruits that are found in the nature, they also contain some acids, so they are considered as organic acids, children. So when you compare these mineral acids and organic acids, you can see that mineral acids are more stronger acids than these organic acids. Examples of strong acids are hydrochloric acid, phosphoric acid, we have like HCl, hydrochloric acid, phosphoric acid, sulfuric acid, etc. And coming to the weak bases, we have acetic acid, we have oxalic acid, we have lactic acid, etc. Acetic acid is actually a mineral acid, but still it is weak acid. Oxalic acid, lactic acid, all these acids are found in the fruits and vegetables which are found in the nature. They are organic acids and they are weak acids. Coming to strong bases, actually. So strong bases examples are sodium hydroxide, potassium hydroxide, calcium hydroxide. Weak bases examples are ammonium hydroxide and some carbonates also. Now coming to the concentration, and mainly let's come to the concentration now. Concentrated acids and dilute acids. What do you mean by them? More amount of acid and less amount of water, if it is present, then we call that as a concentrated acid. Then what is a dilute acid? it is diluted or mixed with more amount of water actually. So diluting also is a, like we have to take a lot of care while diluting an acid also. Never pour water in acid. Always we have to pour acid in water. So here, because it's an exothermic reaction, lot of heat is liberated. So once if you pour water in acid, suddenly all the water, it changes to what you call steam, and there is like a chance of explosion, like, so it spills out, like it's very dangerous. So always add acid in water, but not water in acid. So that is how dilution is done. What is diluted acid? It is nothing but a solution containing more amount of acid and more amount of water and less amount of acid. Okay. Coming to the indicators, we have been learning this since our lower classes, like 7th, 8th, 9th, 7th and 8th. We have learned about these indicators, natural, and basically there are two types of indicators you have learned, but now you will be learning about third category also. One is natural indicator, another one is artificial indicator. So you can see that natural indicators are many actually. You can use turmeric as a natural indicator, litmus is a natural indicator, you have China rose indicator, red cabbage indicator, you have some plants also like hydrangea plants which give different colored flowers in acidic and basic medium, and we have like in that way we have like one more synthetic or artificial indicators also, like the phenolphthalein and the methyl orange indicators. Okay, which give, what are indicators? These are the chemicals which give a different color in different media. Like in acidic media they give a different color, and in basic media they give a different color. So we can't just put our finger and test whether it is an acid or base every time. It is very corrosive, it's very harmful, or neither we can taste it, right? So in order to know the quality or nothing but whether they are acids or bases, to discriminate, we use certain chemicals which are known as indicators. They tend to change their color when they are in acidic or basic media. We have olfactory indicators also. That means we can identify with the help of the smell that these indicators have. For example, onion, we have clove oil, the spice clove oil, or we have onion, and we have vanilla essence also. So they have their own characteristic smell, isn't it? So that smell, usually in acidic media, the smell is retained. You don't find them these onion or clove oil or the vanilla extract to lose their characteristic smell. They don't lose their characteristic smell in acidic medium, in acids. But in case of bases, like they lose the smell is lost completely. Then we can understand that it is basic media. That is about the indicators, children. Now, very importantly, subject point of view also, this is very, very important. What are the chemical properties of acids and bases? Very important subject point of view. Definitely it will be asked in the examination. Sure, short questions. Not just in this. I am not talking about present assessment, but I am talking about the board examination. Board examination point of view, this is very, very important. You should have a clear idea about how acids react with all these. So at least these you should have in mind, bear in mind. Acids, when they react with metal, which gas is produced, children? Hydrogen gas is produced. Acids, when they react with a metal like a sodium or calcium or magnesium, then what happens? Corresponding salt, their respective salt and hydrogen gas is released out. When they react with metal carbonate, again metal carbonate, please remember, whenever carbonates are there, whenever there are carbonates, when they react with acids, carbon dioxide gas is released out along with salt and water. Okay, children, metal carbonate also is somewhat basic in nature. So when a base react with acid, you get salt. Okay, salt, and we get carbon dioxide because it has carbonate molecule, isn't it? Carbonate ion, it has that will be released out in the form of carbon dioxide. Okay. Then we have water. So water also gets released out because the neutralization is happening. Then you see we have metal hydrogen carbonate. You can see that here also carbonate is present in the structure, which gets released in the form of carbon dioxide, and metal hydrogen carbonate also is basic in nature, and that's the reason why acid reacts with basic substance. Whenever acids react with basic substance, salt is produced along with water. Then acids reacting with metal oxide. What are metal oxides? What is the nature of metal oxides? They also are basic in nature. Always remember, metal oxides are basic in nature and non-metal oxides are acidic in nature. So the basic oxide reacts with acidic substance and then a salt is formed because some neutralization happens and water is released out. Now acids, as we know that acids react with base, that is nothing but the well-known neutralization reaction, and it gives rise to salt and water. Examples of all this, you have to really practice all these examples. I am posting along with this, I am posting one study material where you can get all the examples of all these chemical reactions, children. Please go through that and study well. Okay. In the similar manner, we have bases. Bases also, when they react with metal, they form salt and water, salt and hydrogen gas is released here, children. Whenever bases react with a metal, actually here metals like zinc or aluminium, actually when they react, because they are called as amphoteric oxides, amphoteric substances. Zinc oxide and aluminium oxide, they are called as amphoteric substances because they act as with bases they act like acids, and with acids they act like bases. So they are called as amphoteric substances. So again, that's the reason why salt and hydrogen gas is released here. Okay. You can see that when they react with acid, again it's a neutralization reaction. When they react with non-metal oxide, nothing but like CO2 or say for example NO2, okay, then they form salt and water because non-metal oxides are acidic in nature. When they react with bases, they form salt and water. Okay. Now let's talk about what acids and bases have in common. Okay. Now as you can see, some examples of acids: hydrochloric acid, sulfuric acid, nitric acid. You can see that all of these have hydrogen in common, children. So these hydrogens, these acids, they give off one proton or nothing but H plus ion when when they are dissolved in water. So they dissociate into hydrogen ion. This hydrochloric acid, it dissociates into H plus and Cl minus ions when it is dissolved in water. And you can see in the similar manner, this also, it dissociates into SO4 radical ion and H plus ion. Here also it is H plus and NO3 minus ion. So you can see that when dissolved in water, the acids actually, they liberate H plus ions. So this H plus ion, this reacts with water, okay, and forms, what is this called? It's called as a hydronium ion. So this is what which gives acidic properties to acid. It's called as hydronium ion, H3O plus. So because of this only, all the acidic properties of acids are given off. Okay. So coming to bases, this is also similar, children. All the bases have OH in common. Can you see here? Sodium hydroxide, potassium hydroxide and ammonium hydroxide, calcium hydroxide, copper hydroxide, all these have OH in common now. So this OH minus ion, they react with the H plus of acids and water is formed. Actually that is nothing but the what you call neutralization reaction happening. Did you understand, children? OH from base reacts with H plus of acid and forms water. That is nothing but neutralizing each other, and corresponding salt will be also formed. This is about acids and bases. What do they have in common? Okay. Now this dissociation is very crucial because this decides whether an acid is a strong acid or a weak acid, children. So here you can see that these all are actually strong acids, and you can see 100% dissociation of H plus ions. If any acid like the acetic acid or the carbonic acid, H2CO3, carbonic acid, those are called weak acids because the dissociation is not completely done there. Full dissociation or complete dissociation of H plus does not happen there. That's the reason why less amount of H plus ions is present, you can see formed in the solution, and hence few molecules of hydronium ions, actually there are only few hydronium ions are formed. That's why acidic properties are also less. So weak acids do not completely dissociate their H plus ions, and this only is the reason why the glucose and the alcohols, in spite of having H plus in their hydrogen ions in their structure, they have hydrogen atoms, they have hydrogen ions in the atoms in their structure, yet they are unable to, they are not considered as acids. Why? Because they cannot dissociate. So H plus ions are not formed when they are dissolved in water, and that is the reason why they are not acids. They are neutral substances. So why, I can ask in the examination, why these substances like glucose and alcohols, in spite of having hydrogen in them, why are they not considered as acids? Not simply having hydrogen atoms in the structure does not mean that they are acidic. They have to dissociate it and form hydronium ions, then only they can be considered as acids. Okay, so the glucose and alcohols do not dissociate and no formation of hydronium ions, so they are not acids, children. Did you get this point? We learned about the indicators there. We learned about 3 types of indicators. What were they? The natural, synthetic and olfactory indicators. So what is their function? Why do we need those indicators? Just to qualitatively analyze, or what you call, in order to just test the quality of the solution. That means whether it is an acid or a base or a neutral substance, that's all. But we cannot say how acidic, how strong that acid is, or how weak an acid is or a base is. So in order to know the strength of the acid or base, that means in order to know quantitatively how strong an acid is, how weak an acid is, or how strong a base or how weak a base is, we need to go for the pH scale, children. Before this, let us understand what is universal indicator here. So what we do, this is nothing but an indicator made by mixing all the indicators actually. So as a result, what happens? Every indicator, will give its characteristic color when it comes in contact with, when it encounters any solution. Say for example, if it is, all the indicators are mixed in this solution. Now when you add acid to it, so those indicators which can give, its color, which can show its color at that particular concentration of hydronium ions, it will give its color. So here, that is how, you can see different colors at different pH scale. So in order to understand universal indicators, you should also have an idea about the pH scale. If it's a weak acid, there will be some indicators which give off color when they come in contact with weak acid. So that color is shown. And there are indicators which give a different color when they come in contact with a strong acid. Like that, for every concentration, for every level or amount of hydronium ions present in the solution, the indicators which are present in the universal indicators give out or show off their own characteristic color. So in order to understand more about it, you have to understand about the pH scale also, children. What is pH scale? It is nothing but, it is the measure of the concentration of hydronium ions in a solution. So concentration of hydronium ions, directly it is a measure of the acidic properties, nothing but its acidity, right? So if you measure this, you can understand how strong or weak an acid is, right? So that is how. So a pH scale is nothing but, P means here potens in German, children. So that means how much of hydrogen ion concentration is present in the solution. It checks it, nothing but it gives a measure of the hydrogen ion concentration present in the solution. So You can understand that pH has readings from 0 to 14. It's like how we have units for measuring different physical quantities, like we have centimeters, inches, meters, etc. In the similar manner, we have pH scale and it has readings from 0 to 14. Then from 0 to 7, if the pH reading is between 0 to 7, it indicates that the solution is acidic, children. The solution is acidic. Acids have a pH value of 0 to 7. It can be 1.1, 1.2 decimals also it can be. In points also it can be. Then if it is 7, then it is neutral substance. Neutral substances have pH of 7. Then 7 to 14. Bases have a pH of 7 to 14. I can ask in the examination a particular solution has a pH of 11.2. Say for example 11.2. What its pH is likely to be? What is the nature of that solution? Then you should say that because it falls in this category 7 to 14, then it must be a base, and it gives the corresponding color. Actually, a pH strips will be available of the universal indicator only, which give different color at different pH values, and that color after dipping into the solution, it can be checked that shade of the color can be actually correlated, or it can be compared to the color chart that is shown on the pH strip. Then you can actually find out the scale, actually whether it is acidic, neutral or basic. So I have already given you that material actually for of the color range of the pH scale. Actually please go through it and understand that 0 to 7 it is acidic, 7 is neutral, and 7 to 14 it is basic. Okay children, let's recall what we learnt about salts in our chapter. We learnt that salts are the ionic compounds which are chemically neutral. So we all know that salts are formed by the neutralization reaction between acids and bases. So another definition also I told you that for example, if you take any salt, any acid, if you take for example, the H plus is actually replaced by a metal. The H plus is replaced by a metal. What we get is nothing but a salt. So you can see here, this is also another definition in which whenever the H of H atom of an acid is replaced by a metal, what you get is nothing but salt. So these are the neutral substances, ionic substances. I told ionic compounds because they are held together by the forces of very strong forces of attraction between the positively and the negatively charged ions. Actually, if you see NaCl, the Na plus and Ca minus, this ion and this ion together, they are held with very strong forces of attraction actually. So that's why that's the reason why they have ionic compounds have very high melting and boiling points. So these are very strong compounds actually, ionic compounds. So some of the common salts that we see are nothing but the table salt or the common salt. We have other salts like sodium carbonate, and sodium hydrogen carbonate. If I add 10 water molecules to it, it becomes washing soda. So all these are types of, for your assessment, for tomorrow's assessment, we have only these three: sodium chloride and washing soda and sodium hydrogen carbonate for tomorrow's assessment, children. Okay. Talking about the common salt, like we have, how do we get common salt? It's again by evaporation of seawater, or we can get it from the underground actually, what you call mineral, which is nothing but the rock salt. That is another, way how we get sodium chloride. Rock salt is nothing but, it's a mineral actually which contains more of sodium chloride. Now sodium chloride, what happens to sodium chloride solution, aqueous solution, very concentrated solution of sodium chloride when it is passed, when electricity is made to pass through this brine solution. We call this as brine solution. Brine means what? It's concentrated sodium chloride solution. So when electricity is passed through brine, then what happens is we get these compounds, very useful compounds actually, like sodium hydroxide, hydrogen and chlorine. You get hydrogen at the cathode, very important, chlorine at the anode. Cl minus ions, minus means they are anions, they move towards anode. H2 nothing but H plus ions, they are all cations and they move towards cathode, children. So hydrogen gas is collected at cathode and chlorine gas is collected at anode. Along with that we have sodium hydroxide also, which is present in the solution, which is formed in the solution. So all these three are very, very important. Uses also, I have given you some material where, you know, even in your textbooks you have nice uses given about sodium hydroxide, hydrogen and chlorine. So you can see here the sodium hydroxide, very important. These also, children, please make sure that you practice. So when sodium chloride is made to react with ammonia, carbon dioxide and water. So ammonia, NH3 is ammonia. Then formation of sodium hydrogen carbonate and ammonium chloride. So here you can see ammonium chloride is formed along with sodium hydrogen carbonate. So this is nothing but called as a baking soda, right? Sodium hydrogen carbonate. This has also got so many examples, so many uses and applications also, children. You can see that this sodium hydrogen carbonate, when it is heated, it decomposes into sodium carbonate and carbon dioxide gas is released along with water, and this is the reason why it is used in various dishes actually, like for making the dough or the batter of dosas, idlis or cakes, you know, fluffy. So this carbon dioxide gas which is released during this heating, you know, this reaction, it makes the dough or the batter very fluffy and very soft. The dosas or the idlis, they become very soft because of the release of this carbon dioxide gas only. You can see that one more substance that is formed is sodium carbonate. So this sodium carbonate, when it is dissolved in water, it takes the water of crystallization. We call this as water of crystallization because these molecules of water are present in the structure of the crystal. Okay. So then, you know, they form crystals of sodium carbonate. I told you that if it is only Na2CO3, then we call it as sodium carbonate only. It's not washing soda. If it has 10 molecules of water along with it, then we call it as, what is that? Washing soda. Washing soda is also called as sodium carbonate decahydrate. Decahydrate means 10 molecules of water are present along with the structure. Got it? So till here you are going to have your assessment tomorrow. Please do practice, very importantly, the chemical reactions of acids and bases, and very importantly what is this process called, children? This process is called as chlor-alkali process. You remember? Because chlorine gas is released and also a very important alkali is produced. A soluble base is produced. Very strong base, sodium hydroxide, is produced. So it is called as chlor-alkali process. Now, as I told you, please practice these all reactions. Surely they are going to come, and don't be scared, don't be stressed, because the exam is going to be very easy. You're going to do definitely well. Okay? All the best.